Okay, this is section 2.6, limits at infinity. If you look at the graph here, you can see that as the values of x get very large, the graph appears to be approaching the horizontal line, y equal 1. So we express this as the limit as x approaches infinity of f of x is equal to 1. Now, if the values of x get very large, but in the negative direction, so for like example, negative 1 million, negative 2 million, we can see that the graph is approaching the x-axis, so that's the line y equals 0. And we write that the limit as x approaches negative infinity of f of x is equal to 0. Just for the sake of contrast, over here you can see this is the limit as x approaches 3 of f of x is negative infinity. So here we have a limit at infinity, and here we have an infinite limit. Every time we have a limit at infinity, we get a horizontal asymptote. So this is the horizontal asymptote y equal 1. And this tells us that we have the horizontal asymptote y equals 0. Another quick example, if we look at the exponential function, we know that the graph looks something like this. And the limit as x approaches infinity of the exponential function, so as x gets very large in the positive direction, is just infinity. And the limit as x approaches negative infinity, so as x grows large in a negative direction, the limit in this case is just 0, because the graph is approaching the x-axis. I'm going to do a couple algebraic examples with no graph so that you know how to do these. Now, if you recall, this is a rational function, and since the degree of the numerator is the same as the degree of the denominator, we know that these terms, which dominate, give us a horizontal asymptote of y equal 5/2. So we're going to use limits to understand why that's the case. The first thing I'm going to do is I'm going to think about what happens if I was to just try to plug in huge values of x. I can see the numerator is going to head towards infinity, and the denominator is also going to head towards infinity. This is not equal to 1, by the way. It is an indeterminate form, and it tells us basically no info about the limit. So we have to do some algebra. What I'm going to do is I'm going to divide the numerator and the denominator by the highest power of x found in the denominator. So in this case, that's x cubed. And I'm just trying to get rid of that infinite factor that's causing this behavior. So if I divide through by x cubed, then in the numerator I get 5 plus 3 over x squared plus 1 over x cubed. And in the denominator I get 2 plus 7 over x squared. So I want to compute this limit. I note that since x is blowing up, x is getting huge, this expression is going to approach 0. I have a finite fixed number that's being divided by a number that's growing very, very large. And so this approaches 0. This will have the same behavior. It will approach 0 as x approaches infinity. This will also approach 0. Now the limit laws apply because all these limits exist, so that the limit of this quotient of sums is going to be equal to the sum of the limits divided by the sum of these two limits. So I get 5/2 is my limit. So now this matches with the horizontal asymptote that we would have gotten in our algebra class. Okay, so let's do another example. So x is approaching negative infinity. This is similar to the previous example, except I have a square root here. So I'm going to have to think about how to deal with the square root. Again, the highest power of x in the denominator is x cubed, so I'm going to divide through by that. Okay, now I want to bring the x cubed into the square root, but I have to be a little careful to note that since x is a negative number, and the reason I know x is negative is because I'm approaching negative infinity here. Since x is a negative number, we have that x cubed is equal to negative square root of x to the 6th. So I need to have this negative sign here because this is a negative number. And then this is, we know, positive until I add this negative in front of the square root. So I'm going to rewrite this as negative square root of x to the 6th. And I'm just going to work on the denominator here. So this becomes 1 plus 8 over x cubed. Continuing. And now I'm going to combine my two roots. So I have 9x to the 6th minus x over negative x to the 6th. And my denominator is the same. Now I can simplify inside the square root, and I have 9 minus 1 over x to the 5th, over 1 plus 8 over x cubed. Now, don't forget the negative sign here. Now, as x goes to infinity, this expression is going to go to 0. This expression is also going to go to 0. And we get the limit as x approaches negative infinity. This is actually just approaching, let me cross this off, negative root 9 over 1, which is just negative 3. So that's our limit.